Let's explore the concept of work. Let's say you want to move a big heavy object. In order to do that, you're going to have to apply a force to the object that is greater than the frictional force that is acting on the object. So let's say your object starts at x equals 0. When you apply a force greater than the frictional force, you move the object. Now the object is at x equals a. We can calculate the amount of work done if we know the applied force and the distance moved. So we integrate the force from where we started to where we ended up over the distance moved. There are a number of things to note here. First is that work is associated with the transfer of energy. Secondly, that transfer of energy always occurs because of an imbalance of forces. Let's apply that concept of work to something a little bit more chemical. We have here pictured a piston containing gas particles. The forces acting on the piston are due to pressure. Remember that the pressure is the force per unit area. So the pressure of the gas particles pushing up on the piston is the force of the particles striking the piston divided by the area over which that force is acting, so the area of the piston. There's also air or gas particles pushing down on the piston from above, and so there's an external pressure and an internal pressure. When the internal pressure is greater than the external pressure, the piston will move up when the internal force is greater than the external force. And thus we have done work on the piston. So we can see that the gas pressure inside the cylinder has pushed the piston up through a distance x equals 0 to x equals a. So we can calculate the work done on the piston by using our formula for work. So the work will be the integral over the force applied, which in this case is the pressure times the area of the piston over the distance dx from 0 to a. Notice that a times dx defines the change in volume in the cylinder. So we can write the work done on the piston as V1 to V2 P dV. However, we're not interested in the work done on the piston. We are interested in the amount of energy transferred from the gas to the piston. In order for the work to be done on the piston, the gas has to have transferred that equivalent amount of energy. So the work done on the piston is equal and opposite to the energy transferred as work from the gas. So the work of the system, the work done by the system, is the opposite. This type of work is called pressure volume work, and this is the type of work that we will be most interested in during our study of thermodynamics this semester.